So another way to do this is not necessarily going too above and below. You still need to know 95% is the middle 95% that we're talking about for a confidence interval, meaning that there's 2.5% below and there's 2.5% above that we don't want to include in this. So one way of thinking about this is what's a critical value, and that's this value up here. And the probability from that point and below is really 95% plus 2.5%, or 0.975. And the trick with this is if you look in your table and you try to find where what z-score we're talking about, that's going to result in a probability of 0.975 or 9750. You can find it by looking for 0.9750 in the table. This one corresponds to a z-score of 1.96. Now that makes kind of sense because we thought 2 above and 2 below. Doesn't matter if you use 2 or 1.96. We're going to get very similar answers, because this means 1.96 standard deviations above the proportion and below the proportion. So one idea is if we take the standard deviation and times it by 1.96, this is how much above proportion we should be. It's also how much below the proportion we should be including. So if we take the proportion and sum 2 standard deviations higher, or 1.96 standard deviations higher, this should be our upper bound of our confidence interval. And that looks very similar to what we just had. We also want to take our proportion and subtract 2 standard deviations, or 1.96 standard deviations, to find the lower bound, which is almost identical to what we had before as well. You're allowed a little difference in numbers. I think the difference for our numbers come at the thousandths place or the hundredths place. So we could have these answers in as well. And that's the idea of a confidence interval. I wanted to show it to you where you actually figure out 2 standard deviations above and below, or how you can also use a z-score to help you do your calculations.